Good morning everyone. So we are nearly at the end of the summer term and we've just got 2 lessons to go. Today we're going to be looking at combining transformations. The biscuit that's going to help us through that is the, wait for it, if I can get it out. It's the Fox's Double Choc Crunch Cream. Now I don't really know much about these. I mean, I'm a big fan of the Fox's Crunch Cream, but the ginger one and the golden one, but I haven't had these before, so we will see how that goes. I'm sure it's going to be great. Now, as far as combining transformations is concerned, you first need to make sure that you can do single transformations, and so we'll go through those very quickly. And if you've got a problem with those, I'll give you a place you can go to practice them from the GCSE part of the Maths Genie website. Right, there are 6 basic transformation types that we're going to be using and combining. The first one is what happens if you have an a inside the bracket of the function. So that's within what's happening. We need to think it through. Now what I'm going to do is I'm going to show you how you could check these sorts of things out with a calculator. So I'm doing it with the sine curve, and because the sine curve goes up in quite big jumps of degrees, I'm going to add 30 on. So what happens, according to this, is a translation of a minus a, so it moves it negatively on the x-axis. Let's just have a little look at that, and it does. You can see the red line has gone to the left. The reason for that is when you put the red value in before the function is applied, the a is being added to it, which would move it to here. So what we're saying is if we put in that red value, what comes out is the blue value. So when you add something in, it moves to the right. If you were to take something, it would move to the left. Okay. Next up, we get what happens when you add a value after the function has been applied, which is what this is saying. According to the textbook, this is what would be given. So if I put that in here as well, with the one after I've closed off, so I know I'm getting that afterwards, and I hit draw, then you see that the function has been drawn up. It's exactly above the blue line, exactly one above, and I added 1. So that one's a simpler one because the whole function's been applied and then it happens. You don't have to think about what's going on inside the function. Right, for the next, I'm just going to delete these and keep the sign next so we see what's happening. Now, if you've got a multiplier inside the bracket, that's going to look like, well, we'll have 2x instead of x. And apparently the horizontal stretch factor would be a half. What does that mean? Well, let's have a little look first of all. And those of you doing physics, it's like the frequency of the curve has doubled, hasn't it? That's what I like to think of, because we're multiplying. I think, yeah, actually what's happening is you're getting the curve happening a lot more times, which some people think of as a shrink, because the whole thing's shrinking back. So you can say it's a scale factor of half, that's correct. You could also think of it in terms of frequency. So the whole thing is getting condensed and squashed in. Right, so that one was a little bit confusing. If you put the multiplication out before the function like this, then that's going to be sort of similar to the first one where the thing's happening outside the bracket. So you work it out and then you multiply. That's going to make the stretch happen within the y-axis because it's making your result actually much bigger. Let's try that out then. So if I put in 2 sin x and press equals and then draw, this is the green one this is going to be. So there come those two, and notice the frequency is exactly the same as it was before. So when all your roots happen in exactly the same places, but the magnitude of the wave has doubled, so it's stretching on the y-axis. Now these last two conditions I'm going to sort of do together because they are sort of the same sort of things, but when it's inside and outside the bracket. So the one when it's minus x, we're just going to look at that first. So if you make it negative before you put it into the function like that, so it's minus x cubed. I've gone for x cubed instead of because it's going to be easier to see what's going on. So the blue line is our positive one, our red line is our negative value of x instead, and you can see that that is reflected in the y-axis, and that's because we've made every x value, all of our inputs that were positive have become negative, and the ones that were negative have become positive, so it's just flipped everything over. Now what happens if you do the negative just to the whole thing? Well, that does it the other way round. So if I type that in here, you've got minus, and then if we put x cubed plus 2 into the bracket like that, and then press x cubed and draw, then the green one, don't get confused by the red one, because it looks like it's just the red one moved down, but actually we're looking at the blue and the green is a reflection of the blue in the x-axis. Now if you found all of that was just a nice little revision thing and you're ready to move on, then that's great. The rest of the video is for you. If not, if that was new, then you'll want to watch that again, think about it, and if you go on to mathsgenie.co.uk and follow this route, the GCSE revision page, go to the grade 8 to 9 topics, transforming graphs, y equals function of x, then that should give you all the practice you need. Once you're good at doing those, you'll be ready to start combining, which is what we're going to do now. Here's our first example, so you'll want to make a sketch of this yourself. I'm going to do the first one on here, and then we'll do some others on others. Now if you want to, on other sketches, if you want to pause it and see if you can have a go at doing all of this without me explaining it at all first, then I think that'd be a good thing to do. Get as far as you can, and then start checking back and seeing what I do as I go along with it. So we're going to look at each one separately. Now before I do this, I'm going to firm this in with a pen, because we've got two different graphs. We've got two functions that I'm going to be applying on this first one. So it's 2 times whatever this function is, that is this one here, and then we're taking 1. So the first thing that's going to happen, you can just use basic bid maths, and the first thing that's going to happen is this part, isn't it? And this is happening at the end, because subtraction is the last thing to happen. So the first thing we need to do is multiply whatever the resultant of the function is by 2. So that means that my effect on y is going to be doubled. So when I put 0 in, I'll get double that out. So that point there is fixed. Whenever I get 0, that will be the same. So these root points will be the same, but they don't actually really matter, because we haven't been given what they are, so we're not expected to know them. What we are expected to know is that this is going to double here. So this distance below is going to double down to here, and this distance here is going to double, so that's up to 4, so that's going to go up to 8. 5, 6, 7, 8. And I'm just going to put this bit in lightly with pencil for now, because what I'm drawing here is the y equals the 2 of the function, and now I've just got to think, right, now it's going to be minus 1. Well, we know minus 1 is after the whole thing's happened, it's just being shifted down 1. So that means that my final result, which I'm going to do in red, is going to be 1 below. So my new point here becomes 6, and that was 8, so take 1 is 7. My new point here was at 2 minus 2, so that's going to become at 2 negative 3, and then the rest of it we'll just sketch through as was, and those points are going to be slightly different to where the roots were because the whole thing's moved down, so that all becomes irrelevant anyway, and we are no longer knowing where it's going to the origin. But what we do know is, because that's dropped down exactly 1, that we can put in that point there as being 0, negative 1, because we do need to put in anywhere where it passes the coordinates that you can see. So that is the first one done, y equals 2 fx minus 1. Before we move on, I should have just labelled that what it was at the end. So that is 2fx minus 1. Right, so on the next, we have got the part B one. So this is what this looks like in the beginning. So if we deal with what's inside the bracket first, so our value of x is having 2 added to it before the function is applying. So our value of x is actually 2 smaller than we thought it was, which moves everything to the left 2, doesn't it? So I know that those 2 points are going to go to there, that point is going to go to there. So that, I'm not going to sketch the whole thing in because it gets messy. I'm just thinking that's where my important points are. Then what's happening? We're adding 2. Well, if we add 2 afterwards, that's an effect on the y axis, isn't it? So we're moving up 2 to there, up 2 to there, which is at 1, isn't it? And then up to here to the point negative 2 and 2. I know all of those points, and I can sketch those in, which I'll start and it doesn't really matter where it goes after there. The important thing that we get in here is that I've gone 2 to 4, so that is at 4, and then it's gone up to 6, so that's become from 6 4 to 4 6. This has gone from 2 negative 1 across to here, and then up to here, hasn't it? So I've drawn that in the wrong place, which is why we use a pencil. And so that means that actually my curve is looking a bit more like that now, because I've got that other one in pencil there as well. I am going to just make sure I know that this is the one I'm really serious about. And I can put that on there, and I've clearly labelled that point. I just need to clearly label this point here as well, so that is 0 1 as that other low point there, and I do know that that point there is negative 2 2, so it's good to label that one too. Right, so now I've got y equals a quarter of the function 2x. So the first thing we're going to do is we've got to deal with what's inside the bracket, haven't we? So 2 times, if you multiply what you're putting in by 2, then that's the one that creates the, it's a bit like a shrink, or you could think of it as happening many more times and increasing the frequency. So that's going to condense everything along here by a half. Anything where it's equal to 0 is staying the same for now, and then it's going to reach that twice as fast, so that's going to go to there. It's also going to reach the 4 at half the value of x, so when x is equal to 3 it will reach 4. So those are the two really important points, that one there and that one there. And then what we've got to think is, what happens if you then do a quarter of that? Well, that's what's happening to the result. So you've worked it all out, and then it's having a quarter, which is going to shrink it still further, because that's going to be 1/4 on the y-axis. So instead of being 4 there, that's going to go to 1 there. So that is 3, 1 as the top of my curve. And then instead of being -1 there, that's going to be -1/4 or 2.5. So we are thinking 1 -1/4 there, and then that is what's happening to our curve. Now that doesn't look too good there, so this is one where I'm going to draw it out again. As I do this, I'm thinking, what were my important points? Now I know I've only got to go as high as 1 or so, so if I put 2 there, and now I know it was to do with quarters, wasn't it? So if I go 4 squares for each one, that's helping me a little bit, just to be clear about it. Now you won't have squares in the exam, so it is just about drawing the right number on there, but it's always reassuring to get it looking about right, I reckon. So we've got the 0.31, didn't we? So if I just go along and make that 1, that 2, that 3, then 3, 1 would happen there, wouldn't it? You've got your 1 -1/4, so that would be -1/4. And the important thing here is just to make sure that you name all your points. So it's 1 -1/4. It's still going through the origin, remember, because the roots are unchanged by what's happened. So I'm going through there, and then making the curve basically look the same, because my axes have grown bigger. It suddenly looks the same, although in reality it was much smaller, wasn't it? And I'll make sure I put that point in there, 3, 1, and then we're done for that one. Right, so here's the last one. So we've got a lot of negatives going on here, but the first thing to do, and if you get really confused, remember, just doing the first thing will get you some marks, won't it? So the first thing is to sort out what's inside the bracket, isn't it? So what's happening to x before the process is applied is we're taking 1 from it. So that means that's when it's going to end up having the effect of moving it the opposite way on the x-axis, isn't it? So everything's going to be +1 in this direction. So I know I'm going to get a point there, a point there, a point there, and then I'd draw my curve through. Now, having done that, in fact, I'm just going to sketch it in lightly, I think, because having done that, the whole thing is going to get reflected. Now, which axis is it reflected in? Because the whole thing has happened, then we're making that negative. What's changing is what it looks like for y, isn't it? Because that's your result. So we're saying, right, I've got this result, and if I was having a result that was this one here, which was at 7, 4, that's going to be turned to negative. So the y result, that result is the y value, isn't it? That's going to go across over to the other yes, it's the y that's changed, but that does, sorry, the y result is changed. So it's not a reflection on the y-axis, is it at all? It's a reflection in the x-axis, because my result has become negative instead of positive. So instead of being at +4, that's going to go to -4. So that is 7, -4. This one here, instead of my result being -1, that becomes +1 when x is 3. So that becomes 3, 1. 0 is 0, so that stays the same. Oh, except that that 0 has been moved along, hasn't it? That was all moved to 1. So, sorry, that root there stays the same at 1. And then we are just sketching that down there, and we are reflecting this really light line that I did here, aren't we? So that goes down to there, and it's doing something like that. So if I make that red to make that as clear as possible, and you can always make another sketch once you've done this and say, right, okay, now I'm going to do my clean version. So 7 minus 4 is there, 3, 1 is there. There are important points, and that is y equals -x minus 1. Okay, we're upping the game here. If you want to drop this one down and have a think about it, see what you think you might do. They haven't sketched the graph at all for you this time. They've just told you that it is, function of x is equal to ln x. So we need to start by sketching that graph. Now, you might be confused about what that is, so what could you do? Well, I'd say you may remember exactly what it looks like, but if you don't, remember your calculator is your friend here. So you get into your graph function, you hit ln x, press equals, draw, and you may need to play around with the axes a bit, but that's enough to remind us exactly what's going on here. So your natural logarithm, you've got an asymptote at the y-axis, and I left that off my question. Actually, we should have we need to know where the curve crosses any axes, and we also need to state any asymptotes. So if we start off by sketching what we've just got here to start us off with, and what do we know? Well, we know that the asymptote here is the y-axis, and it's not crossing the y-axis ever. It crosses the x-axis once, and because this is the reflection of e to the power x, and when anything to the power of 0, anything to the power of 0 is 1, that means that it's a reflection of the point 0, 1, and therefore we've got 1, 0 there. So we know it's going to cross at that. And if you couldn't remember that, of course, you could hit G solve and hit root, and it will tell you that point. So let's just sketch in first of all. There's point 1, and that's all we need to start off with. So for the first one, we've got our function that's being multiplied by 2, and then we're taking 3. So we need to do the multiplying by 2 bit first of all. So when x is 0, it's not going to change the whole thing. We'll be getting twice as steep, which isn't going to be making too much difference here, but it does mean that it's going to continue up there. up there, and then we're taking the 3 as well, and that's all getting a little bit. How are we going to work out what that value is? Well, for that we're going to have to solve the equation for when we're getting 0. So the function of x is ln x, so we can say that y is equal to 2 ln x take 3, and we want to know when y is going to equal 0, so we can say y 0 equals 2 ln x take 3. So going back into your thing, see if you can solve that equation. Keep it nice and simple. Add 3 to both sides, gives you 3 is equal to 2 ln of x. We can then divide by the 2 and we get 3 over 2 equals ln of x. And at this point, this is when you start thinking about what do logs mean. And this is your natural logarithm, isn't it? So we are saying that the power is that, our answer is that. So we are saying that e to the power of 3 over 2 is going to be equal to x. And at that point, it's time to get the calculator out again and just go shift e to the power of 3 over 2 is equal to 4.48, or you could say e to the power 3 over 2, couldn't you? So 4.48, and then our sketch is just simply going to be 4.48 there, and then all we have to do is show that going off in the same sort of way. In fact, that's not very nice, is it? Let's do that again, and because it's been multiplied by 2, we know it's sort of going up a little bit steeper, so it's nice to draw it going up, so it's looking a bit steeper than that one there. But all you have to do is put your 4.48 there and state that the line, the y-axis, which is called x equals 0, isn't it, is an asymptote. And we've done that one, and we've just got this to have a look at. And I forgot again, but I should have labelled that line, shouldn't I? Right, so here we go. We've got the last one here. And what do we do first? Well, the first thing to do, sort out what's in the bracket. So if we apply the negative before we do the operation, then that's going to mean that when I put in 1, I'd get what I get for -1. When I put in -1, I get what I get for +1. Therefore, I'm going to have a reflection in the y-axis, aren't I? So I always like to think these things through instead of just trying to sort of dumbly remember a bunch of rules. So that is going to be y equals f of minus x. Now, what we've got to do is we've got to do the modulus of that. So the modulus, that means we're only allowed positive results, doesn't it? We're looking at the magnitude of what's going on. So at this point here, this is all positive results. That's a magnitude of 0, so that'll stay as 0. As soon as it goes to -1, that's a magnitude of +1. So all these numbers here, this bit here, is going to get reflected like that. So we can then just put in that bit there to label this and say, right, that's the bit that I want. Maybe it's nothing wrong with showing a bit of working, maybe just show that as dotted, or show that it's clear that that's the line that we are going for. And that's all the examples for today. You're probably quite relieved at that. And I'm just going to give you 2 to have a go at. If you feel you need to do more practice, then you can find more in the book. But if you can do, there's plenty of practice within these questions, to be honest. So we're looking at page 47. I'll post these on to the end of the video as well. Exercise 2F. And we're looking at question 1, which has got a few different ones to practice on it. And then we've got an exam style question of question 4 on the following page. Before I put those up on there, I just realised I forgot to label that point there as -1, wasn't I? So that's -1, 0. And I also forgot to say that the line x equals 0 is an asymptote. So hopefully you spotted that before I did. Okay, goodbye.